Hey, 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 everybody. Welcome back to chapter 6. So now we're going to talk about energy for muscle contractions. So the only energy that is directly usable by our muscles is ATP. ATP is stored in very small amounts in our muscles, and so it's used up really quickly. So there are three basic mechanisms that we use to make more ATP. There we go. The first is through direct phosphorylation of ADP. So this is with a protein that's very specific to our muscles only. It's only found in muscles, and that's called creatine phosphate. A lot of you have probably heard of creatine, especially if you're into muscle building, because they have creatine shakes that you can drink that increases the amount of creatine in your body. What creatine does is it combined ATP, it holds the phosphates from ATP and allows us to store a lot of ADP in our muscle fibers. And then when we need a really quick boost of energy, we can add phosphate to ADP, producing ATP. And then, of course, we have our aerobic pathway, aerobic respiration, which is where we get the majority of our ATP energy. And then finally, we have anaerobic glycolysis. So this is a quicker response to needing energy than the aerobic pathway, but it produces a very small amount of ATP, and it produces a lactic acid, which is dangerous to our bodies. So let's look at each of these a little bit more closely. Like I said, we have very small amounts of ATP that can be stored. The majority of the ATP that's in our muscles at any given time will immediately be broken down into ADP, and the phosphates are going to attach to creatine. Then when we do need ATP, the ADP that is in our cells, which is easily stored, can pick up the phosphate from the creatine in an exchange reaction, and we produce more ATP that can be used. So this can give us a very small amount of energy, about 15 seconds. If you're thinking of like a run, the first 15 seconds of that run would be in using this creatine phosphate. Then we have aerobic respiration. This is where we're going to produce the majority of our ATP. So for those of you who have not heard about aerobic respiration yet, this is a process of how our cells produce ATP. We use oxygen, and glucose together provide us with a lot of ATP. So we, in general, produce approximately 36 ATP that are usable by our cells. 32 of those ATP are directly from aerobic respiration, and then 4 are through anaerobic processes in that entire process. So this is where most of our energy is going to be produced, is through this process. But I know that everyone has had sore muscles. So if you've ever worked out and you have sore muscles and you're like, oh my God, I was lifting weights or I was running and my legs hurt or my arms hurt, that those sore muscles come from when you are using more energy than aerobic respiration can provide. We move into an anaerobic process called fermentation. And so fermentation occurs through the process called glycolysis, and we produce, as a byproduct of fermentation, lactic acid. Lactic acid, when it builds up in our muscles, causes our muscles to ache and eventually will cause our muscles to just stop working. So if you've ever been exercising a ton and then your body just gives out, you're like, nope, can't do anymore. I can't even lift my arms. That's because you have too much lactic acid produced. And the best mechanism for fixing that is actually to stretch get your body moving a little bit, get that lactic acid release so that the liver can convert it back into pyruvate, which can be used in aerobic respiration. So muscle fatigue, it occurs when you've used your muscles for too long, especially when you don't have enough oxygen, and so you end up using anaerobic means like fermentation to produce the majority, or not the majority, but to produce some of your energy. So if you are working out, you're exercising, you're running, you're, doing whatever, then you're going to end up in oxygen deficit and muscle fatigue. And that's kind of where this cute little cartoon picture comes from. He obviously was working out a lot. When this happens, you're going to have to take in more oxygen. So that's why at the end of any exercise, you're always breathing heavy to try and get more oxygen in, get rid of any excess carbon dioxide that's in our system. The oxygen then can bind to our hemoglobin molecules, as well as in our muscle fibers, we have myoglobin that binds oxygen. So we replenish the oxygen stores that we have. We need to reproduce creatine phosphate. So the ATP that was there is going to be broken down to ADP plus the phosphates. The majority will, and will increase the amount of creatine phosphate we have. We're going to have to get rid of the lactic acid. So part of the reason we move into muscle fatigue, like I said, is because we have a lot of excess lactic acid being produced, or a lot of that lactic acid being produced from fermentation. So when we relax, when we start stretching and relax, that releases that lactic acid from our muscles, moves it into our blood, and can move to our liver where we can reproduce the pyruvate, which is not dangerous for our cells. So the next thing we're going to talk about are isotonic and isometric contractions. I was trying to find some cute pictures to show you the difference. So here we're seeing an isotonic contraction. Isotonic contractions are the ones that we're typically we know about. So this is where you use your muscles, you are shortening those muscles and then increasing the muscle length. So you are contracting and relaxing those muscles. So think about walking, moving your arms, doing anything. That's all isotonic contractions. Isometric contractions then, and this JPEG, or this GIF, that's what it's called, came from this website right here. An isometric contraction, oh, I hope I didn't go too many. I did. Yep, I'm sorry. Nope. Well, it is, but I'm on this slide right here. There we go. All right, an isometric contraction then is a contraction where the muscles don't move. So the muscles stay the same length. So think of same length contraction, isometric, versus isotonic, where we are increasing and decreasing the muscle length. So in isometric contractions, the muscles are still functioning, they're still working, but the muscle length does not change. So when you're doing like a plank for a minute or 2 minutes or whatever you can do it for, you're in an isometric contraction. And this is also linked, which is what I was going to by accident. I didn't mean to. So you can click on this and you could actually go to that website, okay? The last thing in this video I'm going to talk about is muscle tone. So when people think of muscle tone, they think of, oh, being toned, having nice looking muscles, but that's not what I'm talking about when I say muscle tone. I'm talking about muscles being in a continuous contraction state. So we have large groups of muscles that have to continuously contract. Think about the muscles in your back that help you to sit straight. if you're watching this video and you're sitting, you're using those muscles right now to help you keep your back erect. Actually, the muscles are named for what they do. They're called erector spinae muscles. To do this, you cannot continuously have one muscle fiber stimulated all the time, which is why we have multiple muscle fibers in any given muscle. And so we stimulate some of those muscle fibers to allow us to stay erect. And then we stimulate other ones the next time so that our muscles can constantly have a relaxed period in between the stimulation. So we don't end up in that tetany that we talked about earlier. So muscle tone allows us to maintain posture at all times. And this picture actually is linked also, so you can go right to that web page as well. All right, the last, so I'm sorry, one more thing. I said that was the last, but one more thing. How do we increase muscle size or strength? There are two different ways. We can do it through aerobic exercises or resistant exercises. Aerobic exercises are things like running, jogging, biking, walking, anything that increases our heart rate is considered an aerobic endurance exercise. And this causes or allows us to increase our metabolism, as well as it improves digestion. So if you've ever, say, felt like you were unable to poop, one thing that you can do if you are constipated is exercise. It actually increases movement of materials in your GI tract, allowing you to go to the bathroom easier. Another thing, of course, would be drinking water, because a lot of times that's what's causing constipation. The other activity you can do to increase muscle size and strength again is resistance training or weightlifting. So in this case, you are exercising and you're increasing the size of each muscle fiber. So here we have an individual who is in running, so this is an endurance exercise. And here we have an individual who is lifting weights. This is a weight lifting exercise. Both are beneficial to maintaining muscle strength as well as muscle tone for the body. So I'm going to stop here, and your next video will be on the second part of the chapter. So I'll talk to you later. Bye.